Hi, I'm Guang, 15 years old. In this lesson on limit calculation, we have another lesson showing an example of a limit. So this limit here, we are given what its result is, but we are not given some of its coefficients or constants. So in this type of examples, we will have to determine whatever these coefficients or constants are. Right. So now we'll take a look at the example we have in this lesson. So we're given that limit x approaches to positive infinity, x squared plus 1 over x minus 1, then minus alpha x minus beta is equal to 1. So of course we will need to find the value of alpha and beta. Okay, so in order to find these two values, we are going to split them into three separate methods to solve, alright? So in our first method, method 1. So in this method, let's combine them into a single fraction. So limit x approaches to positive infinity, x squared plus 1 over x minus 1 will now also have to subtract alpha x plus beta, then multiply by x minus 1. Alright, so now this is equal to 1. So what is so special about doing this? So what if we just expand whatever we have inside first, alright? So limit x approaches to positive infinity. So now we are going to see something over x minus 1. Now you take a look at the numerator. So we have x squared plus 1 and expand whatever's inside here. But of course we would like to combine the terms of x squared, combine the terms of x, and combine the constants. So in terms of x squared, you're going to have an x squared and a minus alpha x squared. So here you have 1 minus alpha, then x squared. So afterwards, then you're going to have x term. We're going to have beta, which becomes a negative beta x, then add on to alpha x. So you're going to have to add alpha minus beta x. Alright, and lastly, it will be the constant terms, which is 1 and beta. Okay, so now this is what we are looking at. So what else can we do over here? Now in this method, what we're going to actually use is the conversion from infinity calculation to infinitesimal calculation. So let me just write that down. So think about it, conversion from infinity calculation to infinitesimal calculation. What do you think will be our next step? Well, of course, since by its title, changing it from infinity calculation to infinitesimal calculation, what we are going to do is to divide both numerator and denominator by x. Well, what we're going to see is limit x approaches to positive infinity. Now we're going to have 1 minus alpha x plus alpha minus beta plus 1 plus beta over x, then over 1 minus 1 over x. So originally it is infinity over infinity. So let's take a look at what kind of form we have now. So in the numerator, x, well, that probably is still in infinity, but then you have a constant plus 0 over 1. But then you look at your original question. This is equal to 1, alright? So since this should be equal to 1, you cannot have the infinity term in your numerator. So since you cannot have this infinity term in your numerator, 1 minus alpha has to be equal to 0. So then you can quickly deduce that alpha is equal to 1. And the next, of course, will be your final result, where you realize after you remove this term, it will just be alpha minus beta over 1, which is alpha minus beta. So alpha minus beta needs to be equal to 1. And you get this simple set of simultaneous equations, where since alpha is equal to 1, beta will be equal to 0. So these will be the two different results that we get, alright? So, alright, now since this is what we are going to have, so that will be for our first method, where we change from infinity calculation to infinitesimal calculation after combining them into a single fraction, then dividing both numerator and denominator by x. Right, so that's the first method. I hope that you're clear of that. So next we'll be moving on to the second method. So in our second method, what we are going to do is so in this second method, there are other different ways that you can look at it. For example, you can once again combine them into a single fraction, but this time try to factorize them instead. So you have limit x approaches to positive infinity. Then since you will still have your x squared plus 1, then minus alpha x plus beta, or you could just not do this altogether since you're factorizing, so actually the part behind is already factorized, and what you can do is to instead make it become an x squared minus 1. Then since you make it minus 1, so you need plus 2 behind in order to make it the original one. Then you have over x minus 1. Alright, and the rest is minus alpha x minus beta. So this method will be factorization, and so what do you think would you need to use afterwards? So of course you're going to have to separate them into two, well, not exactly two different fractions, but since you can separate them, what you will have is limit x approaches to positive infinity, then you'll see x plus 1 plus 2 over x minus 1. Then from here you're going to have minus alpha x minus beta. Alright, so this is pretty much what you are going to see afterwards. So pretty much you can just say that this is some kind of factorization. Alright, now let's take a look at what can we deduce from here. Now it is pretty much the same things. You have x term, you have a constant term, and you have a term that if you sub x in, you'll pretty much get 0. Which means, once again, 1 minus alpha, which is the coefficients of x, these would have to be 0 in order to get your 1. while for the rest you have 1 minus beta, which is equal to 1. Alright, so in this case you have this kind of simple pair of simultaneous equations. Well, once again you get alpha is equal to 1 and beta is equal to 0. Alright, so this is the second method by using factorization and partial fractions, if you want to say it. Alright, so that's pretty much all that we've used in the second example, in the second method. So in these two methods, they seem pretty similar by using simultaneous equations and getting your alpha and beta. But how about we have another method which is a bit different, alright? So in this method, it will probably be one of the most common methods you might see, since it is a very convenient method. Well, it depends on you, alright? So the only thing about the third method will be you will have to combine them once again into a single fraction. So in the third method, we'll be using the L'Hopital's rule. Right, so L'Hopital's rule, we're going to have limit x approaches to positive infinity, and we are going to see x squared plus 1 minus alpha x plus beta x minus 1, then divided by x minus 1. So for this case, or this method, we do have an infinity over infinity situation. Well, it is continuous and differentiable, so yes, we will be able to use the L'Hopital's rule on this. Well, when you differentiate both numerator and the denominator, what you're going to have is, in the numerator, 2x, then since 1, well, it's just gone, so minus alpha x minus 1, then minus alpha x plus beta. So this will be divided by 1, which technically, if you already saw it, you don't need to write the 1. But for this term, or this part over here, you can rearrange them. So limit x approaches to positive infinity, you're going to have 2 minus 2 alpha, well, you could already take out a 2, and then you're going to have the constant terms. We're going to have plus alpha minus beta, and this will be equal to 1. Now, once again, you take a look at the term with x, which means, once again, it is also pretty much similar. Well, you have 1 minus alpha is equal to 0, and alpha minus beta is equal to 1, and thus alpha is equal to 1, beta is equal to 0. Alright, so there you go. You have 3 different methods to solve one example here, where you're given x squared plus 1 over x minus 1 minus alpha x minus beta, and this when x approaches to positive infinity, the limit is 1. Alright, so the 3 different methods that we have used. The first is a conversion from infinity calculation to infinitesimal calculation. Well, we combine them into one fraction, then divide up both numerator and denominator by x, then form some simultaneous equations to solve it. Now in the second method, where we had factorization and partial fractions, we had 2 different parts. Then we took a look at the first fraction. In the first fraction, we essentially just factorized and used partial fractions, then once again made simultaneous equations to solve alpha and beta. Then in your last method, we just use the L'Hopital's rule in order to differentiate both numerator and denominator, but you will have to be aware you have to combine them into a single fraction in order to do so, and ensure that it is of the indeterminable form, either 0 over 0 or infinity over infinity, which the latter is our case here, and it has to be, of course, continuous differentiable. And then afterwards, then you'll get some more simultaneous equations that you can solve. Alright? So I hope for this lesson, these three methods, you're clear of all of them so far. I will be ending this lesson here, and thank you for your watching.